So I think we can start. Welcome again, everybody, to this webinar. My name is Nora Minas, and I'm here with my colleague Johannes Müller. Both of us work as data analysts at ecoinvent. Today, we will talk about the electricity sector in the ecoinvent database and the use of ecoinvent data for GHG reporting. Before we start, I would like to give you some information about the webinar. So you're all muted, and if you have any questions, please use the dedicated question tab, which you can see in your GoToWebinar window. We will then either take the questions during the webinar or at the end of the webinar, where we'll have some time for a Q&A session. Anything which we cannot address today, we will follow up via email later on. We will be giving the same webinar tomorrow, and one of the recordings will be uploaded on our YouTube channel, where you can also find recordings of previous webinars given by the ecoinvent Association. After the webinar, you will receive a short survey where you can express how you perceive the webinar, or you can give us some suggestions for improvements or ideas for upcoming webinars. And we would be very grateful if you could take some time to answer the survey. With this, I would like to leave the word to Johannes, who will be talking about the electricity sector in the ecoinvent database.
Thank you very much, Nora. As you said, we will first have a look at the electricity sector. We will see how electricity mixes in ecoinvent are modeled, how electricity is produced and distributed, and we will have a look as how you as a user can view and access this data. In the first step, I will quickly build an overview of the modeling of the electricity sector, and then we are going to have a detailed look at the individual components. So, at the core of the electricity sector are the three markets of the three voltage levels. We have a high voltage, medium voltage, and low voltage markets. These markets exist for most of the countries in ecoinvent, but also on other levels, as I will explain to you later. We have feeding into those markets. We have electricity producing activities also on all three of the levels. We have electricity demanding activities, again on three of the levels. And then we have electricity transformation activities that connect the three voltage levels. And at last, we have imports feeding into the high voltage. This is a summary of the electricity sector, how it's represented in ecoinvent, and now we're going to have a look at the individual components. I will start with the voltage levels and the markets. So we have three different voltage levels that we call high, medium, and low voltage. The high voltage level is defined as electricity with a voltage of above 24 kilovolts. We have most of our large electricity producing power plants that feed in this into this level of the grid. There is the long distance electricity transmission that happens on this voltage level. And we have losses that occur during transformation and transmission. The medium voltage level we define as a voltage between 1 and 24 kilovolts. There is electricity that is transformed from the high voltage to the medium voltage, which also includes losses. And we have some power plants that feed the grid directly at this level, which, for example, are waste incineration plants. And as consumers at this level, we have large industries like paper mills that use the electricity directly from this grid. At last, the low voltage level is defined as electricity that is below 1 kilovolt. This is again transformed from the medium voltage level and includes also transformation losses that occur. We have, as producers, we have photovoltaic that occurs here and feeds directly to the low voltage level. And as consumers, we have usual households, but also small businesses and like normal consumers. In the next step, we will shortly look at the electricity producers in ecoinvent that then in turn feed into the markets. I will not mention all the technologies by name, but just quickly the fuels, so you have an overview of what production means we have. As you will see on the slides, there are, for most of the fuels, there are multiple producing technologies available. So we have electricity produced from hard coal, from lignite, through natural gas, from oil, from peat, by nuclear power plants. There is a hydropower production, there are photovoltaic data sets, there's wind power, there's concentrated solar power, but also geothermal and electricity from biogas and biomass. And at last, we also have electricity that is produced as a byproduct from industrial processes. Here, as example, I mentioned pulp production and petroleum refinery production that produce electricity and then feed it as a byproduct. As the next step, we will come back to the electricity markets and look at the transformation that happens in them. So we have transformation and transmission happening in all the markets. And the transmission is modeled by 3 infrastructure data sets. So on each of the levels, we have inputs of infrastructure that bring impacts from the production of the whole distribution network to the electricity. There are losses on this level, so in the transformation and transmission that are modeled in the electricity markets, and we use values from the International Energy Agency for each of the markets. So we have individual losses that for each of the countries that are represented in ecoinvent. And here you can quickly see a screenshot of how losses are represented in an ecoinvent dataset. So we here see that the input of an electricity market and the losses for transmission are modeled in such a way that they point back to the market itself. And in this case, the loss is around 1.8%. So the markets slightly have a slightly higher input of electricity than they actually produce. And we also have emissions that occur through the transmission. So in the high voltage levels, we have dinitrogen monoxide and ozone emissions that is produced in an electromagnetic field around the area lines of the overhead transmission lines. But there is also sulfur hexafluoride emissions in the medium and low voltage markets. This is used as a quenching and insulating gas in the switchgear. And in the next step, the transformation between the markets is taken care of by individual data sets that we call electricity voltage transformation from high to medium voltage and electricity voltage transformation from medium to low voltage. These again cover losses that we have individual values from the International Energy Agency. And these look like this. So a data set produces, for example, the electricity voltage transformation from high to medium. It produces 1 kilowatt hour of electricity at medium voltage and is fed by the high voltage electricity with a certain factor. So this factor represents the losses that occur during the transformation. And next, there is the electricity imports that occur on the high voltage level. So imports are represented as a net flow from one geography to another. So even if there is a bidirectional flow of electricity, only the resulting net flow is represented. We do not model exports explicitly, but only imports. So the imports are only present on the high voltage level, and they themselves do not contain any losses. They only serve the purpose of linking different electricity markets to each other. So we have gone through the overview. I will not present to you the electricity demanding activities. As you can imagine, these are of many different sorts and cover practically all the sectors. But we will now have a short look at additional modules of the electricity sector. So we have the usual electricity markets that normally represent a single country, but we also have some exceptions where the electricity markets are on a regional level. So we have specific markets in the US, in India, in China, and Brazil, and these markets represent the regional electricity grids. So the physical region where a grid is, the grids are distinguished from each other. And for Canada, we have electricity mixes per province. And we also have a concept that is called a market group, which is, it's like a combination, and the idea is that it represents a larger region than we usually have for the electricity markets. So there are market groups for practically all continents, but there are also specialized market groups like the ENSO-E and UCTE that represent a grid, connected grids in Europe. And we also have a global market group that represents the global electricity production. A quick word on data sources and where we get our information that we feed into the electricity markets from. We have several sources that we use to update the electricity markets, and these include statistics from the International Energy Agency, statistics from the ENSO-E system operators, and for the US, we use a statistic for the eGrid, and there's a national statistics that we use to model these regional markets, as in Brazil, India, and China. In the electricity markets, the shares that are represented there usually refer to a specific year. So for the year, for the version 3.8 that was published last September, the markets usually refer to the year 2018, but there are also exceptions like Canada and the US where they refer to the 2019. This information is also in the datasets themselves mentioned in the general comment. And we update these market shares on a yearly basis. So for the version 3.9, we will have the shares will be usually for the year 2019. And also a quick word about our editors. We work together with several editors from different institutes here in Switzerland. So we work with the Paul Scherrer Institute, the Swiss Federal Institute of Technology, and the Zurich University of Applied Sciences that also contribute to the updates of the electricity markets each year. I also have to say that the update of the electricity markets, this happens in the attributional system models. For the consequential system model, we have a slightly different setup. So in the consequential system models, we use marginal electricity mixes, and they are based on projections from the International Energy Agency, and they represent the year 2015 to 2030. There are 14 specific marginal electricity mixes that are based on these projections, here shown in blue. And for the countries that are shown in orange, there is a rest of the world mix that was created. And this mix was calculated by the current policy scenario from the International Energy Agency. And then all the countries here in blue were subtracted. So there is those were not in some way double counted. As in the next slide, I have a quick representation of how a market looks in ecoinvent. So this is how a market dataset is represented in our online platform EcoQuery. As you can see, there is a reference product of 1 kilowatt hour of electricity. There are some emissions that I mentioned before, and these occur on the high voltage level. And then there are several inputs of electricity. And if we expand one of these entries, we can see that here in this specific electricity market in Japan, we have an input of a nuclear pressure water reactor of around 3.1%. We also have an additional file available that facilitates the view of these market shares. It's called market composition and is available in the files section of EcoQuery. So if you click there, and then you will find under supporting documents, there are all the additional files available. And as you can see here, we have also a specific electricity analysis file that is available if you want to go into make a deeper analysis of how electricity is modeled. And this electricity analysis file is available for all the system models. And I will now give you a quick live demo of the file and explain to you how you can use it to go into more depth if you want to know more about the electricity markets and the fuel consumption, fuel mix, etc. So I will quickly switch to my file. As a first tab, we have a README tab that explains the different tabs available in the file. And this is just for a quick reference. If you do remember what the tabs are supposed to represent, here is a quick and short explanation. So we will start with the first tab that's called Activity Chain. This tab might appear a little bit overwhelming, but just bear with me and I will explain how it works. So as many electricity markets have imports, it is not always apparent what the exact fuel mix of this country is. So an import simply links to a different country with that can again have different imports to other countries. So it is hard to backtrack to exactly say what a fuel mix of a specific country is. So this sheet aims to unravel this chain and show the contributions of electricity producers from other countries and that contribute to a specific market. As an example here, I have filtered for the high voltage market of Albania. And in the column H, there is a level column. And as we can see here on level 1, this level represents the normal electricity market that we could also see in EcoQuery or in the market composition file I've mentioned earlier. And as you can see, this market is fed by a hydro run-of-river, and there are several imports, in this case from Greece, Macedonia, and I do not know the last abbreviation by heart. And now we say, okay, we follow the electricity that is imported from Greece. And we see here then in the second level, we see that the electricity from Greece links to the import data set. And the import data set links to the market for electricity high voltage in Greece. And then if we go down a further level, we see that here on level 3, the market for electricity in Greece is represented. So this market through the import data set feeds into the Albanian electricity high voltage market. And for each of the entries, this pathway can be seen in the activity chain column. So here we see, in this case, we have lignite production in Greece, goes back through the high voltage electricity market in Greece, through the import data sets to the market in Albania. And then the interesting part is here in the columns on the right. So columns Q and R represent the shares of lignite in the Greek market. So if you would look at the high voltage market of Greece itself, but then in column R, we see the percentage of this that it contributes to the Albanian market, so to the market selected at level 1. So we can read from this table that 2% of the Albanian electricity comes from the Greek lignite input, lignite production. And this file is also used in the rest of the tabs that then are aggregated and shown in a different way. But first, we will have a short look at the losses tab. This is again filtered for the electricity market in Albania, and in this case, the low voltage market. And what it does is actually simply it aggregates all the losses that occur during the whole production and transformation and distribution line until it appears in this market. So in that case, we will have transformation losses from high to medium and from medium to low, including transmission losses. And we can read that to produce 1 kilowatt hour of low voltage electricity, we actually have to, wait, the other way around, to supply 1 kilowatt hour of low voltage electricity, we have to produce 1.2 kilowatt hours. And the next tab, that is called supply mix per fuel, is actually a aggregation of the first activity chain tab. And this now shows here filtered as an example for the high voltage market in Spain. It shows the share of electricity produced by different fuels. So if we take the imports into account and aggregate them, so by summing up the whole chain we have seen in the activity chain tab, we can come up with the actual fuel mix and see how the electricity in this country is what it is comprised of, or what the actual producers are. And there's a similar tab here that is called contribution IPCC that shows the contributions of global warming potential by the different fuels. Here now grayed out, as this is a licensee only information. And here you can see, for example, how much hydropower in terms of global warming potential contributes to the high voltage electricity market, again, in Albania. And the second last tab, production mix and import, is similar to the supply mix per fuel. But here imports are listed separately, so only the actual production fuel mix is shown. And the share of imports can be here seen in column S. And at last, the fuel classification tab. This simply is a mapping between the fuel classification, the fuel terms that are used in the other tabs, and the electricity production data sets used in ecoinvent. So with this, I would like to end the introduction to the electricity sector and hand over back to my colleague Nora for the second part of the webinar on GHG reporting.
Thank you, Johannes. I will now take over the screen. Okay. So I will now continue with the second part of the webinar, which deals with the use of ecoinvent data for GHG reporting. And I would like to start with a brief explanation on how to find the emission factors you are interested in. So first thing to note is that emission factors, or as we call them in ecoinvent, cumulative LCIA scores, are only available for licensees. So if you do not have a license, you can also not access any emission factors. When we talk about emission factors in the context of the GHG reporting, we always refer to the global warming potential 100 years of the IPCC 2013 method. Here it's also important to note that emission factors provided by ecoinvent usually refer to the entire IPCC method as implemented by ecoinvent. There's an exception for electricity, and I will talk more in detail about this later on. So if you are interested in emission factors for electricity, you can download the electricity emission factors file from the file section of ecoquery. This file lists both scope 2 and scope 3 emission factors for electricity producing activities and electricity markets, and was published with the release of version 3.8 of the database. For all other emission factors, I would recommend the following procedure. I would first recommend to download the database overview file from our website. Here you can see the link where you can find the file. And this file lists all data sets that are available in the latest version of the ecoinvent database. So it's really a great starting point when you want to get an overview about the entire content of the database. As a next step, you can then access ecoquery with your license account or with a guest account. And in ecoquery, you can then search for the data sets you are interested in. The easiest way to do so is by simply copying the name from the database overview file. As I mentioned, with a guest account, you will not be able to see any emission factors. You can, however, still view the data sets in what we call the undefined unit process. So this is the process before linking takes place, so before the supply chain is determined. This allows you to read the documentation of the data set. So for example, if you are interested in the system boundaries, or if you want to know more about sources that have been used in the creation of the data set, you can read all this information. And you can also see inputs and outputs to and from environment and technosphere present in the undefined unit process. With a license, you can also access the emission factors via ecoquery, and this can, for example, be done by downloading an Excel file, which is called the cumulative LCIA file from the file section in ecoquery. And this file contains a list of all LCIA results for all data sets included in the database. Emission factors or LCIA results are available for different system models in the ecoinvent data, so all of the system models offered by ecoinvent. And for GHG reporting, we recommend the use of the cutoff system model. Here I would quickly like to show you where to find the files I just mentioned. So here we are in the files section of ecoquery. And as you can see here under LCI and LCIA results of the cutoff system model, you can find the cumulative LCIA file. So this is the file where you would find the list of emission factors for all data sets. And then there is this electricity emission factor scope 2 and 3 file under the supporting documents. And here you will find scope 2 and 3 emission factors for electricity. We will take a closer look at this electricity emission factors file later on. Okay, so with the following slides, I would like to give you an overview about how ecoinvent data can be used for scope 2 and scope 3 GHG reporting for electricity, as well as for scope 3 reporting for purchased goods, services, and capital goods, transport, accommodation, and waste treatment. And since we were talking about the electricity sector earlier on, I will start with this. So as I mentioned now a couple of times, scope 2 and 3 emission factors for electricity are available in an Excel file, which you can download in the file section of ecoquery, together with an accompanying report. And before taking a look at the file, I would like to point out some key things to you. So the definition of scope 2 and 3 in this file is based on the end consumer of electricity, and Scope 2 emission factors refer to the location-based reporting method, so they represent grid average emission factors. If you are interested in the documentation of the underlying data, this can be found in the datasets themselves, so via ecoquery. For example, if you are interested in the documentation of a certain electricity market, you can access this market in ecoquery and read its documentation there. So let's take a look at the file together. As you can see, the file contains several sheets. Even here in the screenshot, not all of the sheets are visible. Yeah, as you can see here, the file contains a README sheet. So here you can find a brief description of all the sheets that are included in the file, and also an explanation of or a description of the most important terms used in this file. Again, the calculation of the Scope 2 and Scope 3 emission factors is done in the cutoff system model. As you can see here, the file contains 2 overview sheets, and the overview sheets or tabs, they provide the aggregated Scope 2 and Scope 3 emission factors. So what we can see here is that you have the information on the activity name, geography, and reference product. And then here you would see the information on the emission factors. This is not visible at the moment because this information is only available for licensees. So we see here that what you would find here is the emission factors for Scope 2 of the respective electricity market or electricity producing activity. And then you will find information on Scope 3 emission factors. For Scope 3, we did a further differentiation. So here you find Scope 3 emission factors that only include the losses. Here you would find the Scope 3 emission factors that relate to all the emissions occurring along the supply chain but the losses. And then this one is the sum of the previous two. As I mentioned, the overview sheet is available twice. So we can see here one is called all GHGs and the other one is called mandatory GHGs. And this is because we calculated those emission factors with 2 different methods. So here on the one hand, for the all GHGs, we calculated the emission factors for the IPCC method as implemented by ecoinvent. This is what we term all GHGs. And then under mandatory GHGs, we only included the 7 GHGs listed in the Accounting and Reporting Standard Amendment by the GHG Protocol for the calculations of the emission factors. So the included gases for those mandatory GHGs emission factors are carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbon, sulfur hexafluoride, and nitrogen trifluoride. We provide these 2 different types of emission factors because we were not sure which type of emission factors are used by our users, so we got mixed feedback on this, and this is why we are providing both and leave the choice to the user to decide which emission factor is more appropriate to use. Next to those aggregated emission factors, we also provide, in this file, you can also find disaggregated emission factors. So these are then given also as CO2 equivalent per kilowatt hour, but as you can see here, they are given per gas or gas group. And those disaggregated emission factors are available for Scope 2 and Scope 3 and for both calculation methods, so for all GHGs and the mandatory GHGs. What you can also find in the files are disaggregated emissions. So these are then expressed as kilogram emitted per kilowatt hour produced. And again, those disaggregated emissions are available for scope 2 and scope 3, and also for the two different calculation methods. Finally, I would like to point out to you that emissions related to land use change and biogenic CO2 emissions are reported outside of the scopes. So you can find information on emissions related to land use change and biogenic CO2 emissions in this tab indicated here. And those emissions are expressed also as kilogram of gas per kilowatt hour produced. With this, I would like to go to the next categories of Scope 3 reporting and explain you what type of data is available for the categories of purchased goods, services, and capital goods. So the ecoinvent database contains regional and global emission factors for around 3,300 products and services. And the database also contains around 600 emission factors for 600 capital goods, such as, so capital goods are, for example, equipment, buildings, or facilities. In order to efficiently use these emission factors, I think it's important to have an overview about the different types of activities that are available in the database. So on the one hand, we have so-called ordinary transforming activities. These are human activities of no specific type that transform certain inputs into a different output. The emission factors of those transforming activities are cradle-to-gate emission factors. And what you can see here on the right are the minimum boundaries as defined by the GHG protocol for category 1, so purchase goods and services and capital goods. And what you can see here is that the emission factors of ordinary transforming activities being cradle-to-gate emission factors are in line with what is asked for by the GHG protocol. Then there are also so-called market activities available in the database. And market activities provide an average consumption mix of a product for a given region. Market emission factors of market activities are also cradle-to-gate emission factors. However, keep in mind that markets also include transport. They can include losses or direct emissions caused by transmission, distribution, or storage. So this is important to know when you are using those emission factors for GHG reporting. If you are interested in only the market composition, so this type of information that is available in the markets, you can also find this information in the market composition file that Johannes showed you earlier on. And this file is available in the files section of EcoQuery. Then we also have so-called construction activities. Those activities produce immobile infrastructure, and they include the initial construction, land occupation and transformation, but also the decommissioning of the infrastructure. So in this case, in the case of construction activities, we are talking about cradle-to-grave emission factors. Finally, the database also contains service activities. So services are defined as immaterial exchanges, and they contain inputs and outputs required to perform a service on another product without the actual input and output of the product receiving the service. So when we take power sawing as an example, the service of power sawing includes the input of the power saw. It would, for example, also include the input of the fuel that is needed, but the tree that is being sawn would not be included in the service activity. Now I would like to continue with the next category of Scope 3 reporting, and I would like to give you an overview of what type of data is available in regards to freight transport. So in the ecoinvent database, freight transport is given as ton kilometers and can be used for the distance-based calculation method. There are data sets available for road transport, and those data sets cover or are specific for the type of vehicle. So, for example, we have data for the transport by light commercial vehicle or lorry, and then data sets for transport by lorry are further differentiated according to the vehicle size or emission class. Transport by rail is categorized by the fuel used, and then inland waterways, sea and air transport are categorized based on the type of product that is transported. So, for example, for ships, there are data sets on bulk or container ships. On top of this, transportation of refrigerated products is available across all modes. And next to these transport-specific datasets, the database also offers additional information on transport. So you can find information on the average transport distances by mode for all products in the database. And this type of information is included in the market of a respective product. So let's take a look at the modeling of the freight transport datasets. It is important to note that data on transport or freight transport are calculated for an average load factor and include an empty return trip. And those transport datasets include carrier-specific emission profiles. So they include, for example, brake or tire wear emissions. Regarding the emission factors of freight transport datasets include the emissions from fuel combustion. They also include cradle-to-gate emissions of the fuels used, and they include the cradle-to-grave emissions associated with the manufacturing and maintenance of vehicles and infrastructure. So when we take again a look at the minimum boundaries defined by the GHG protocol, we can see that ecoinvent emission factors for freight transport also cover what is here listed under optional. So they also include the life cycle emissions associated with the manufacturing of vehicles, facilities, or infrastructure. This leads me to the next category, which is the use of ecoinvent data for passenger transport. So passenger transport in the database is given as person kilometer. This means one person being transported over 1 kilometer, or simply as kilometer. And in the context of passenger transport, the unit of kilometer refers to an average number of passengers being transported. Again, these emission factors of passenger transport can be used for the distance-based calculation method. There's data available for passenger transport by road, rail, and air. And then again, there's a further differentiation for those data sets. So, for example, for road transport, there's data available depending on the type of vehicle used. And for cars, there's a further differentiation based on the size of the car or the fuel used. Rail transport is distinguished based on the geographical operation. And when we take a look again at the modeling of passenger transport or the emission factors of passenger transport datasets, those are modeled in a very similar way to the freight transport datasets. So again, the emission factors for datasets of passenger transport include the emissions from fuel combustion. They also include the cradle-to-gate emission of the fuels and the cradle-to-grave emissions associated with the manufacturing and maintenance of vehicles and infrastructure. The database also provides datasets for accommodation, which can be used as optional information for reporting emissions related to business travel. And here, the unit used in the database is the unit of one guest night. Datasets for accommodation are available for various comfort categories, ranging from hostel to luxury hotels. And the emission factors for accommodation datasets integrate the inputs of the building construction, consumer goods, as well as the utilities used. Okay, so this leads me to the final sector I would like to introduce to you, which is the waste sector. The ecoinvent database contains datasets for over 600 waste treatment processes, including, for example, mechanical or biological treatment, landfilling, or open dumping. There are also datasets available for more than 60 different wastewater treatment. And then there are 500 country-specific treatment mixes, so those are markets, for common municipal solid waste fraction in Europe, Brazil, Colombia, Peru, India, and South Africa. Next to those waste treatment specific datasets, there's also additional information available in the database regarding waste. So you can find information on the types and average amounts of waste generated from all activities in the database. So for example, in a production of a certain product, you could find the assumption of the amount of waste that are also produced during this production process in the respective production dataset. So let's take again a look at the modeling of the waste sector. Waste and wastewater treatment model direct emissions based on the composition of the waste and wastewater and the type of the treatment. And for open burning and unsanitary landfill, climatic conditions are also integrated in the model. When we take a look at the emission factors for waste treatment, those include the direct emissions associated with the treatment of the waste or the wastewater. They also include the cradle-to-gate emissions linked to materials necessary for the process, transportation and energy inputs, and then finally they also include the cradle-to-grave emissions linked to the infrastructure. So when we take a look again here at the minimum boundaries, we can clearly see that the ecoinvent emission factors go beyond what is asked for in the minimum boundaries defined by the GHG protocol. And yeah, this is important for you to keep in mind when you are using those emission factors for GHG reporting. One last point I would like to point out to you here is that in the cut-off system model, energy produced in waste treatment facilities has an emission factor of 0. Also, this information is of course important for you to know when you are using emission factors for waste treatment for GHG reporting. With this, we are at the end of our presentation. Today we talked about the electricity sector. We showed you how the electricity sector is modeled in the database. We also showed you the different electricity producing technologies available in the database, and then explained to you some supporting files which you can use for extended electricity analysis. In the second part of the webinar, we talked about the use of the ecoinvent data for GHG reporting. We first explained to you how to find emission factors for GHG reporting. We then talked about the availability of ecoinvent data for Scope 2 reporting and the different categories of Scope 3 reporting. And finally, we also gave you an explanation on what those ecoinvent emission factors actually include. Yes, so as I said, we are at the end of our presentation. We still have some time for questions. As I mentioned in the beginning of the webinar, you can post your questions in the dedicated question tab. And anything that cannot be addressed today, we will address later on via email.
So maybe I will start with the questions regarding the electricity. As I can see, there are two that I think make sense to answer to all of you. So one question is it not possible to provide newer data? So I assume this is in regards to the shares of the electricity and to the year 2018 that I've presented in the data sources slide. So we base our electricity shares mainly on the data from the International Energy Agency, and we try to model practically all electricity markets in the world. And there it's kind of a trade-off to, we could get newer data for a subset of those countries. So for most of the Western ones, one could get maybe 2 or 3 year old data. But as we want to model all of them in a kind of consistent manner, we have to find data that is somehow contains all of that. And in this case, it's always like 3 years back, and then the IEA publishes the the final numbers of all countries they collect data on. And there is a second question on what approach would you suggest to model future electricity mixes? For example, how can datasets be edited to represent a higher share of renewables? This depends on how you are using ecoinvent. If you use ecoinvent, the database, through some kind of software like CIMAPro, there you can edit datasets and add, subtract exchanges. So if you would like to model a future electricity mix, of course you need the composition, but then you can use exactly the same schema as we do to model the current mixes. So you could create a dataset or modify a market, add electricity producing activities, edit the shares. If you build the market from the ground, you can also add these emissions and transforming and transformation infrastructure. So I think creating a new electricity mix is pretty straightforward, depending on how you use it. If you're just looking at ecoinvent or just using ecoinvent through ecoquery, for example, you can also collect the electricity producing activities individually and then build your own market by also adding emissions and transformation and transmission losses. We also have one question in the beginning of before the webinar, that was on the different dates that are registered in the market data sets. So if you want to know to which year an electricity market refers to, please always check out the general comment of the data of the market data set in one of the linked system models. So there are other dates in the data set. There are usually start and end dates, which they are more use in active transforming activities that do not change every year. And there is a creation date of the data set that is not linked to the actual shares that are included there. So I think these were the questions on electricity. And Nora, you have some questions you could answer?
Yes, we also got some questions for GHG, use of ecoinvent data for GHG reporting. So one question I would like to answer is how many emission factors directly from ecoinvent can be shared with clients. So here the answer is that you can share up to a maximum of 5 different data points with your clients for free and for transparency purposes. If you want to share more, you need a separate agreement with us. So in this case, please contact us under support@ecoinvent.org for more information. Then we also got a question on if we are providing scope 2 and scope 3 emission factors for, or if we are planning to provide scope 2 and scope 3 emission factors for residual electricity mixes. So here, the answer is yes, we are planning on doing this. We are working on this. However, I cannot give you a time frame on when we will be able to publish those emission factors. Okay. With this, I would like to thank you again for joining the webinar. Please remember that we will upload the recording of this webinar or the webinar tomorrow on our YouTube channel. Please also do fill out the survey you will receive. And yeah, in case your question was not answered today, we will follow up via email. Thanks again and have a good day, everyone.